Good day, Professor Breaker here with New Mexico State University. In this video, we're going to talk about John the Ripper, and it's a little lab that we're going to run through using John the Ripper. John the Ripper is mostly used for cracking passwords. And so how are these passwords stored that we need to crack them? And it has to do with hashing. So hashing is an algorithm that is used to generate a unique random character combination consistently. Okay, so when I hash something, when you get a hash of it, it's going to create a unique random hexadecimal character, and it's consistently, every time you hash it, it should come out with the same character if nothing has changed. It's one way. The same string will always yield the same hash, or like I said, same digital thing. We use it for forensics, and so I'll talk about that in a second. But it'll always use the same hash, okay? So that really works good for passwords. Common hashes are the MD5, SHA1, SHA512, CRC. There's a whole bunch of different ones, different hashes or algorithms that can be used for hashing. It's used extensively for passwords for verifying integrity. So if you have a website and you enter your username and enter your password, it used to be that the username and the password would both be saved in the database. The problem with that was if somebody got a copy of the database, they had everybody's username and password. That was not good, not very secure. It was a terrible security thing. So what they started doing was taking and storing a hash of the password. So you store the username and you store a hash of the password. Then when you log in, you enter your username and you enter your password. It hashes your password, takes that string that gets created, and compares that against the hash that's in the database. Now if somebody steals the database, all they have is a bunch of hashes that really don't have anything to go back to the password. You have to crack it to get the password. Now if you've worked with creating websites, sometimes you'll see a thing called a salt. What a salt is, it's something that adds a little more flavor to the password. So I might have a password of 7 characters, but I'm going to add a salt of 4 characters. So for us, it might be NMSU. Okay, so I have a password of 7 characters. I add NMSU to it. Now it's 11 characters. I hash that, and I store that hash in the database. Now nowhere in the database do I store the salt. That salt stays in the application. So now if I get the database in the application, I can still reverse engineer because I'd have the salt and it would help my cracking of the passwords a little bit. But now if I obfuscate it in my database or in my application, it's going to be really hard to get the salt, find the salt, then you have to go back and crack all the passwords using the salt. It just adds another layer of complexity. So you also oftentimes hear the word salt added to the password, a password salt, and they use that and encrypt all of it to create that algorithm or create the hash that gets stored in the database. And it always has to be that when you enter your username, enter your password, it gets a salt added to it, they hash it, and they compare it against what's in the database to verify that that password is correct or isn't correct. Hashing is also used in forensics to verify that digital evidence has not been tampered with. Again, when you hash something, it can be a string, it can be a whole file, it can be a whole drive. If you take a copy of a drive and you make it into a drive file, you can hash it. And once you get that string, if somebody gets in there and changes 1 byte in that file, 1 bit in that file, and you hash it again, the hash is going to be different. And we can do that with a string. You take a string and add a space to it, and you'll notice the hash changes. It has to be exactly the same. There's a thing called hash collisions, where you'd have maybe 2 strings that you hash them, and the hash ends up being the same. It's like 1 in a billion. And so for everything that we use hashing for, the chance of a hash collision, because we're doing a one-way thing, it's really not an issue. All right, Linux stores usernames in the etc password file, and they store the passwords in etc shadow file. Now, the older versions of Linux stored them together in the password file. They separated it out. The password file, anybody can look at. This shadow file, you have to be root to even look at it to access it. It's very limited. There is a tool that you can get that's called Unshadow that will basically combine the password and the shadow file and make it ready for cracking with tools like Hashcat or John the Ripper. Windows also has passwords, and you can use utility like pwdump to grab the passwords out of the Windows. You have to be administrator, obviously, to get the passwords out of the Windows system. And then you would use the format of LM for Linux. You'd use the format of passwd, and then for Windows, if you're gonna try to crack the passwords from a Windows system, use the format of LM. Okay, so let's go ahead and take a look at this, and we're going to look at a little bit what we did in our lab, or what we're doing in our lab. So in our lab, I have you playing around with basically using openssl and MD5. So we can use openssl, and we can hash, find the hash out for this little line, I love 450, ICT 450 hacking. Okay, and there's the hash for it. And then we can also use MD5 sum. So same, if we give it the same string, it should come out with the same hash. And if you look at it, yes, it is the same hash. Now there's this space and a dash afterwards. Here it has std in before it, but here's the actual hash. And if you look, they match. If we put them right next to each other, they do match. They're exactly the same. And that's what it should be if you're using the same algorithm. Now we can do it a different way. We can flip that around. Instead of doing MD5 sum that way, we can do the echo. And we can do the same thing, echo. Actually, we want to do a dash n here, and then do I. And we're going to pipe that to MD5 sum. We should get the same hash. Oh, we didn't. The dash n messed it up. We don't want the dash in there. There we go. And so we have, again, the 048200. So notice when you make a little bit of a change, and again, I could do the same thing if I just added a space in here. That would make a change, and it's going to give me a different hash completely. So just adding any little bitty change to it. Change from uppercase to lowercase. Let's do this and just change this to an uppercase H. And you'll notice that that makes a change. Completely different hash. So that's what makes hashing so unique. I can save this in my database. Next time somebody wants to log in, I get their username, I get their password, I hash it, and if it doesn't look exactly like this here, then it's going to fail. I'm going to say, nope, doesn't match, you can't log in. And we want to create a file that has a bunch of usernames and passwords that are hashed in it so that we can use it for John the Ripper. And so I can do this real simply manually. Let's clear this up here. Well, actually, let's leave it. We've got the password lists up here. We'll get back to using these. I typed them up faster and brought them in so you guys could see what we have here. Let me see if I can, I think we can zoom in a bit here. There we go. So we have these two arrays or lists in the shell here that we're going to be working with. But we can do it manually. We could do like an echo. And here we would use the dash n's because we don't want a new line. And we're going to echo Linda, colon. And we want to put that in a file called hashfile.txt. And then we want to echo dash n. And this time we're going to do the password 1. And we're going to pipe that to the MD5 hash, or MD5 SUM. Now, when we're piping it like this, normally you would use a dash n, okay? So just a heads up on that. MD5 sum, and I made a mistake in my quotes here. And that should put that, and we want to, let's verify that. I don't know, we'll just go ahead and pipe that to, actually, I'm going to do one more thing here. I'm going to do TR, because there was that space dash at the end here. Let's go ahead and remove that with the trailing command, dash D. And let's put both of those into the hash file .txt file. Now if I hit cat, you can see there's my Linda, and there's the hash for the password 1. All right. So we could do this one at a time. We could add each one of these users up here one at a time. Because I'm a geek and we're all about speeding things up and writing scripts here, I thought it'd be really best to write a script here to do that for us. And we can do that right in the command line of the for statement. So really what we need to do is find out, okay, so what is the index of each of these? So Linda, normally in an array you have Linda's 1 or 0, 1, 2, 3, 4, 5, 6. So if we did 1, it should be Alice, 2 should be Robert, right? So let's go ahead and verify that. It's always a good idea to verify your things, your assumptions first. So if we can do echo $ users and bracket 1, we should have Alice, right? Oh, 1 is showing up as Linda, and 2 is showing up as Alice. So in this shell, we're showing that this is 1, 2, so it's actually it's skipping 0. We can work with that, since as long as we know it, we can work with that. So we can use a sequence command because we want to run both of those arrays together. We're going to kind of use them as parallel arrays. So we can do the echo $seq. Oops, let's do the seq 7. And there we go. We got our numbers 1 through 7, so we can use that for our indexes. So let's go ahead and start up our for command. For AN. Okay, so I did it really fast. In sequence 7, so from 1, 2, 3, 4, 5, 6, 7, we're going to echo users A with a colon to the hash file.txt. And then we're going to do the password 2 to the MD5 son. We're going to remove the trailing dash, space and dash. We're going to put that in the hash file. Let's go ahead and do that right away. And if we do a cat hash file, we should see we've got 2 Lindas in there. They are both the same, so we're getting the right information here. We don't really want 2 Lindas in there, so we can do remove it. We'll do the hash file.txt, and let's just run that for command again. I hit the up arrow. It's really nice in this shell that it does all this. Okay, and hit enter and cat, and there we have our nice file ready for us to test if we can hash the passwords. Now, I wanted to point something else before we move forward here to the next step, and that is I had a user contact me, one of our students contacted me and said, this isn't working at all. And at first I thought, well, maybe you have a different version of bash. And that was my commenter, maybe you have a different version of bash, let me look into it. And I found another computer that was working the way hers was working. She sent me some screenshots, and so I told her to do this instead. And then talking to another user, a student, I was like, I wonder, are we using a bash shell here? And I found out you can find out what shell you're in by echoing 0. I know there's a corn shell, there's a bunch of others. We're actually using Z shell here. So this is the latest version of Kali Linux. I downloaded it, I'm opening a terminal window, and I'm expecting I'm working in bash, but I'm not. I'm actually working in Z shell. So these commands may be a little different in a bash shell, so we probably want to check out a bash shell. Let's go ahead and jump into a bash shell I have prepared already. And let's look at our edit and zoom in a bit. So there's our bash shell, and you can see it's bash by doing echo $0, and you can see this is a bash shell compared to the other one, which was a SZSH shell. So in a bash shell, it was a little bit different, and here's the difference that we found out. If we did the echo and we did $users and we gave it a number, let's go with number 1 again, like we did with the other one, we get Linda 1. Okay, well, Linda is the first one, so let's try 2. And we get Linda 2. Wait a minute, this doesn't look right at all. What's going on? Well, in a bash shell, you actually have to add a curly bracket here and put it at the end. So basically, And then we have Robert. Okay, so Robert is actually the third one. So if this is 2, this is 1, this is probably 0. Let's try it with 0. And this is the problem she was running into. It was giving her all this Linda 1, 2, 3, 4, 5, 6, 7. And that was the problem. So we had to add the curly brackets. So now that we know that this starts at 0, we have to add the curly brackets. We can do pretty much the same thing we did with the other one with the for command. So let's do the for command. So it's for a in, and we're going, well, we have to do our sequence. Oh, but our sequence was 1 through 7. But if you look at the sequence, you see that you can actually use 0 and 6 by providing the beginning and ending numbers. So if I do echo $SEQ, let's put a parentheses in there, SEQ, and I do 0 space 6, now this will generate 0, 1, 2, 3, 4, 5, 6. Well, that's what we're looking for, 0, 1, 2, 3, 4, 5, 6. We're good. We can have our sequence here, so we can do our for statement here. So for a in sequence 0, 6, do dash n, and we want to do the $ curly bracket users. I think I'm going to do the $A to get our variable number in there. And then we also want to add a colon in there. And we want to put that out to the, well, let's just go ahead and put that out to the screen first to verify that it looks good, and then we can stick it in a file. And we're going to pipe that to MD5 some. All right, and I think we're done. All right, and so it gave us really nice output. Looks very similar. Remember, Linda started with a 7. If we compare these, let's compare the first 3, 7C6, and the last 3, E4C. Let's compare those against the other one, 7C6, E4C. I'm assuming these are probably the same hashes, so this should work just as well as the other one. And so with this, we were able to create the same thing. We can just put that into a file. And you'll notice when I use the up arrow on the Z shell, it kept the lines. And here I actually have to go and it puts everything on one line and puts a semicolon in between it. So I'm going to look for the semicolons. And I'm going to actually stick in here over, and we'll call this a hash file 2. And we'll have to do that again over here. We'll put that into 2.txt. We hit enter on that, and let's go ahead and cat it. And there we go. So this is using a bash shell. Again, echo $0 tells us it's a bash shell. If we go into the other one, we can know that it's a Z shell. All right. So that was just creating files so that we can hash it. The next step is finding the word list. We're going to use a rockyou word list. It's included with Kali Linux. It's just a default word list to give you. We can go find it. The first thing we want to do is do a sudo update db. The update DB, basically what it does, it takes the mlocate utility and it updates the database. The database basically has all the files and folders in the whole computer system. And so when you do a search on it, so you do a locate, and you can use the find command, but the locate command is kind of, to me, it's a little easier. Whoops. Locate rockyou. And you'll see that we found it. And I already unzipped it once. Go ahead and let's remove that. Okay, so I have to sudo that. All right, now if I use the locate again, it's still going to find it because I haven't updated the database. And the database updates periodically on its own, but if you're making changes and you still want to use it, you may want to just run the update command again. If we do an ls and look at the word list, you can see it's not there. So even though the mlocate thinks it's there because it thinks it's in its database, it's not there. So let's go ahead and unzip that. To unzip that, we have to use a sudo command, and we're going to use g-unzip. Now, some people use gzip. It doesn't work. It may even overwrite your file. So you make sure you're using g-unzip. I always do a --keep, and then the path to the file that you're extracting. And it should take a little bit, and that looks right. Let's go and take a look at a list here. And now it's showing the rockyou full file is there. If we go and do a cat on the set user, you can see there's all the different passwords that are available to it. All right. So we have a hash file, we have a word list. All we need to do is take John the Ripper and have John the Ripper turn the word list loose against the hash file, and we should be good. One more thing I'm going to do. Okay, there's no such file. That's good. Okay, so let's go ahead and run this. John, and here's our command here, -w, and then we're going to have the pass the word list. W is word list, and then we're going to, the format is raw MD5, and then we pass it the hash file. We should get our, oh yeah, it found those passwords fairly quickly for us. So that looks good. If we want to run it again, we should get the same output, right? No. What happened to our password hashes? Well, here's what John the Ripper does. Once it caches a file and it matches up the hash and hash file, it actually has a little folder. So if we do an ls space -la, you can see there's a .john folder created right up here. It's on the top of this screen here. There's a .john folder created. If we go into that folder and do an ls, you can see that there's two files, log and a pot. Let's look at the log. There's a jog. It says it found, it cracked all these passwords. Okay, so that's good. And it started a new session, load total 7 password hashes, no different salts, remaining 1 password hash, command line, and it's just basically password are stored in the pot file. Okay, let's go look at the pot file. And we can see there's the hashes, and there's the passwords that are coming out at the end of the hashes. It doesn't store the name with them, but it does store the hashes and the passwords and the words associated with them. So if that's the case, it's not going to do it again. It's not going to display it again. If you have to take a snip of that and you happen to do that, all you have to do is remove -rs space .john. Remove that, go ahead and run your John the Ripper command again, and it will give you the hashes again. So if you didn't get a screenshot the first time, you go to the second time and they're not showing up, that's how you can fix it. Just remove the .john file. Actually, just removing the .pot file should do it, but I always remove the whole folder, and we can start from scratch. There you go. We have created a bunch of hashed passwords. We created a password file, usernames and passwords. We did a little bit of fun with Bash and Z Shell, and we used John the Ripper. Hope you had fun with this. Have a great time.